Hello everyone, today we are going to be going over question 10 from paper 1 of the Further Pure Math Sample Assessment Material. Now, this is quite a hefty trigonometry question at 15 marks long. So, let's see what it is asking us to do. It wants us to find the value of h, which is the height of the pyramid, then find the size of the angle between OA and the plane ABCD. So essentially the angle from this line here, this diagonal of the pyramid, down to the plane which is the base of the pyramid. So we can get that by constructing this right angle triangle from O to the midpoint, let's say M, and then M to A, and we can figure out this height. Actually, to find the exact value of h, we would construct this triangle anyway. We would find AM because it would be the square root of 4 squared plus 4 squared if we're looking at this right angle triangle here. So we'd find this, and then we can find this, and find the angle between the plane between OA and the plane ABCD. So it is this angle here, and since this is the adjacent side and this is the hypotenuse, so katoa, we can use the inverse cosine of this over this to get the angle. And then find to one decimal place the size of the angle between the plane AOB and the plane ABCD. So that means we make another triangle from O to M to some arbitrary point, let's call N, and we have to find this angle here. So we can find this side with Pythagoras Theorem from the 12 here and the 4 here, because this is also a right angle. And then once we know this side, and we will know h, and we know this is 4, so in fact we don't even have to figure out this side, but we know this is 4, this is h, and it will be we have the adjacent and the opposite side, so we will take the inverse tangent. Tangent is opposite over adjacent. We'll be taking the inverse tangent of the height divided by 4. And then the midpoint of OA is P, and Q is the point on BC such that BQ to QC is in the ratio 3 to 1. So that means there's the point here, which is P, and there's a point Q, which is here, and this is 2, and this is 6, and essentially we just want to figure out the distance from here to here. And what we will be doing is the method which is kind of like in incrementing the dimensions. So you first have your straight line down to here, and we know this is going to be half the height, and then we take it, so we have it in the y dimension, and then we take it into the x dimension by moving the triangle down to here. So this is like the symmetric opposite of Q, because this is 2 here, and then now there's 4 in the middle. And then we take it into the z dimension, this last one, by making yet another right triangle with P, Q, and this here. So we first find this, and then we find this diagonal from P to, let's call this the arbitrary R. And then we know this is 4, we know this side, we can find this diagonal with Pythagoras Theorem, and then find to one decimal place the size of angle PQA. And now PQA will simply be, this is quite an interesting problem. I will come to this later. Alright, so first we want to find the exact value of h. So we know that we have the triangle here, O, M, and A. So AM squared is 4 squared plus 4 squared. So AM is root 32, which is 4 root 2. And then h squared is equal to OM squared, which will be 12 squared, because it's the hypotenuse squared, minus 4 root 2 squared. So minus 4 root 2 squared. And then this is 144 minus 32, which is equal to, let's see, 112. And so the value OM, or which is equal to h, this is a 1 here, not 1.12, this is 112, will be equal to root of 112, which is actually equivalent to 4 times the square root of 7, because 112 is 7 times 16. Now, this is 4 root 7, and we can say that h is 4 root 7, which is equal to 10.58 something something centimeters. So the exact value of h would be 10.6 centimeters to 1 decimal place. And now we can move on to question B. Find the size of the angle between OA and the plane ABCD. Now, as I said earlier, we will take the inverse cosine of AM divided by OA. So the desired angle is angle OAM and my apologies, we should probably make it clear that M is the midpoint of the plane. So let M be the center of ABCD. Now, the desired angle is OAM, and then angle OAM will be the, since this is a right angle, the inverse cosine of the adjacent over the hypotenuse, because it's so katoa. So 4 root 2 over 12. And then you get angle OAM is equal to, and the inverse cosine function, you really just have to use a calculator for this. There is no easy way out using pen and paper. You get 61.87 something degrees. Or 61.9 degrees. So this is our answer here. And this is our answer here. Now, let's look at question C. Find to one decimal place the size of the angle between the plane AOB and the plane ABCD. So AOB and ABCD. Okay. So what we did there is we let N be the midpoint of AB. And then we will see that the angle we are looking for is the angle at N of the triangle ONM. So if you have this triangle here, and there's a right angle, and there's O on top, and M in the middle, and N on the side, we are looking for this angle. So angle ONM is the desired angle. And we know that NM is 4 because it's half the way across the square. OM is 4 root 7 because it is h. And this is enough information to work out what angle this is because we can use the inverse tangent function. So tangent is opposite over adjacent. You can use tan -1 of 4 root 7 over 4, which is just equal to inverse tan of root 7 to find the angle ONM. Alright, so you plug this into your calculator, the inverse tan of root 7, and you find that the angle ONM is something like 69.295 something degrees. Or it is equal to 69.3 degrees because they are asking for the answer to one decimal place. So now, this is a much more complicated question. The midpoint of OA is P and Q is the point on BC, such as the ratio of BQ to QC is 3:1. So it's splitting it up into 4 parts, and then Q is just 1 part away from C. Now, the method I'm using to get this value is kind of complicated, but basically it rests on the fact that first we calculate the distance that we need to go in one dimension, then we calculate it in the next dimension, then we calculate it in the final dimension, and that will tell us the overall distance we need to go, because we calculate this line here once we know how much down and how much right we're going to go, and then once we know how much backwards we're going to go, we can find this one. So remember, first we're going to calculate this, and then we know this to be equal to, I believe it is 6. And then we will calculate this hypotenuse part, and just to remind you that this is P and this is Q. And next we'll calculate this hypotenuse, and we know this is 4, and okay, we can calculate 2 because there is a right angle here, and then the final answer PQ we can calculate because there is a right angle here as a consequence of the method we are using. So just to recap, there are the 3 dimensions. You have the up and down, left and right, front and forward and backward. First we calculate how much down we are, and then we know how much right we are, so then we can find a value for this, and then we factor in how much backwards we're going, so we can calculate this. Alright, so let's just do the calculations now. So let P be above perpendicular to a point R on ABCD. So that is this here. PR is equal to h over 2 is equal to 2 root 7 because P is halfway up OA. I mean, this should be A, my apologies, and this should be O. And since we know that is 2 root 7 and this is 6 centimeters, let's make the other arbitrary point here S. So let R be closest to the point S on BC. And this is really a way of making sure they know what we're talking about, because this is really on the line BC in the pyramid. And we know that RS is equal to 6 cm, PR is equal to 2 root 7 cm, and so PRS is a right angled triangle, and we can use this fact to calculate the distance PS with the Pythagoras theorem. So PS squared is equal to 6 squared plus 2 root 7 squared, and this evaluates to 36 plus, well, 2 root 7 is root 4 times root 7 is root 28, and root 28 squared is just 28, so 36 plus 28. And then we get that PS squared is equal to 64, and PS is equal to 8. Now finally, we know this distance is 8, and that distance is 4, so ultimately it will be quite simple to work out the distance PQ. So we know that since RS is equal to, okay, so since RS is perpendicular to SQ and PS is basically a line RS but is rotated about this line SQ, PS will also have a right angle to SQ. So since PSQ is a right triangle, PS is equal to 8, and then SQ is equal to 4, and therefore PQ squared is 8 squared plus 4 squared, which is equal to 64 plus 80, 64 plus 16, which is equal to 80. And finally, after all this work, you can take the square root of both sides to find that, that PQ is equal to the square root of 80, which is root 16 times root 5, which is 4 root 5, as described in the original question. Now, I will admit I did have a peek at the mark scheme for this, but the logic holds that if you use this kind of method where you're just slowly incorporating every of the 3 dimensions into your distance calculation, so first you figured out how much down it was, and then you incorporate how much right it is, and then finally you incorporate how much backward it is. And that's how you find the final distance between 2 points anywhere in a 3D place. So we have proven that PQ is 4 root 5. Now, find to 1 decimal place the size of the angle PQA. This is quite the interesting calculation. So what I think is that we will have to use the cosine rule to find out the size of the angle, because the calculation for as to what QA is would be quite trivial, since A, B, and Q lie on a right angled triangle where BQ is 6, AB is 8, and this will obviously be 10 because this is like the Pythagorean triple of 3, 4, and 5. And so we know that AQ is 10. We know that AQ is 10. We know that PQ is 4 root 5. And we know that AP is 6 because P is the midpoint of AO and AO is 12. So now let's go write this out in working, and we will use the cosine rule, the c squared equals a squared plus b squared minus 2ab cos c, to figure out the angle PQA. Now, let us get to work. We have our answer for D here, and now we will give our answer for E. ABQ is a right angle triangle. Therefore, AQ squared is equal to 6 squared plus 8 squared is equal to 100, and then AQ is equal to 10. And using the cosine rule, on triangle, what it wants us to calculate, PQA, I think. Yes, PQA. And we will do this on the next page since there's a hefty amount of calculation involved. We have the triangle PQA and PQ is 4 root 5 and AQ is 10 and PA is 6. Now we are finding this angle, so let this side be little p because it's opposite the point P, and then this side is little a because it's opposite the point A, and this side is little q because it's opposite the point Q. We have c squared equals a squared plus b squared minus 2ab cos c. And we convert this into the ones we are looking for. So we are looking for angle Q. So Q squared is equal to a squared plus p squared minus 2ab cos Q. And we know that Q is equal to 6 and P is equal to 10. And finally, A is equal to 4 root 5. So we will know that 6 squared is equal to the square of 4 root 5, so that's 4 root 5 squared, which is going to be 80, plus p squared, minus 2 times a times p, so that would be 2 times 4 root 5 times 10, or 80 root 5, so minus 80 root 5 cosine q. So 36 is equal to 180 minus 80 root 5 cosine q, because this is equal to 80 and this is equal to 100, so obviously they add up to 180. And then subtract 180 from both sides so that we are left with just the cos q term, and you get minus 144 is equal to minus 80 root 5 cosine q, and then divide both sides by minus 80 root 5 to get cosine q is equal to 144 over 80 root 5. And this is equivalent to, as both sides are divisible by 8, I believe. So you can cancel stuff out, and you will get 18 over 10 root 5, and yes, we can cancel this more to be 9 over 5 root 5. And finally, we'll just take the inverse cosine of 9 over 5 root 5. So q is cosine negative 1, 9 over 5 root 5, which will be equal to 36.39 something something degrees. So 36.39 degrees, which will be equal to 36.4 degrees. So Q is equivalent to angle PQA, which is 36.4 degrees as our final answer. Now, if you have somehow managed to watch this entire half-an-hour video, I applaud you, even though you're probably doing it at 2 times the speed by my advice, because I am aware that I do talk quite slowly, especially when thinking. And alright, so we'll recap this whole process. We find the exact value of h from this right angled triangle here, AMO, by constructing the right angled triangle from a corner to the midpoint of the square, and then find to one decimal place the size of the angle between O and the plane ABCD. So we'll find the angle here using the right triangle OMA, and then find to one decimal place the size of the angle between the plane AOB and the plane ABCD. And we can construct yet another right angle triangle here. We don't have to find this side ON, but since we know NM and OM, because OM is equal to H and NM is equal to half of the side of the square, which is 4, we can take the inverse tangent of the opposite over adjacent, so the inverse tangent of H over 4, to find the size of the angle here. And then we have these arbitrary points P and Q, which are somehow separated from each other in the 3-dimensional space. So we have P and we have Q, and then first we calculate the distance from P down to the X and Z plane at which Q is lying on, so the Y distance it moves. And then we know the X distance it moves, so we will calculate the new distance here, and then we take into account the Z distance it moves, which is the front and back axis. So it is the distance here and the distance here. Make up a right angle triangle, and first you solve for this one, and then you take the right angle here and you solve for this one, and you will finally know the distance between these 2 points in the 3-dimensional coordinate space. And then find to one decimal place the size of the angle PQA. and we figured out the distance AQ, and then since we know PQ, QA, and AP, since AP is just half of OA, which is 12/2, which is 6 centimeters, we can use the cosine rule to determine the angle Q from the fact that we have knowledge of the lengths of all three sides of this triangle. Now, pardon me, I'm so sorry. Let us go to the mark scheme. Right, so they have dedicated quite the space. This is for the other paper. Aha, this is what we are looking for. Now, let M be the midpoint of diagonals AC or DB, blah blah blah. So we said it was the center of the plane ABCD, but it is probably better to say it is the midpoint of one of these diagonals because they want you to be more precise about what center you are actually talking about. And we find H with the Pythagorean theorem, then we can find this angle with the inverse tan of H over something else, and we got 61.9 degrees. And then let N be the midpoint of AB. As you can see, I kind of looked at the mark scheme before, but honestly, if you had started taking arbitrary letters from M as your midpoint, because M is traditionally the midpoint of something, and then you can just continue through the alphabet from there, you would probably find the same result. Angle the plane AOB makes with the horizon is the inverse tangent of the height over the half part of the square. You know what I'm talking about. And we got this, so that's correct. We got this, that's correct. We got this, that's correct. And then this method here is a long-winded description of our increasing dimensions method, as in when we find the down and then the right and then the back, and at each step we take into account the new dimension and calculate the new distance. So, yep, for root 5, that was correct. And finally, it was the inverse cosine of this absolute mess of an equation. We just happened to simplify this down further beforehand. So we found the length AQ, and then we took the inverse cosine of this behemoth of an expression, and we got 36.4 degrees. Yep, so this was right, this was right, this was right, this was right, this was right. And since we provided explanation, despite the fact that it may not have adhered exactly to the mark scheme, the guidelines Edexcel gives their examiners is very likely to give you 15 marks for this question. So that was quite satisfying. I thank you very much for watching. Yep, that's it. Thank you for watching.